We're going to do more examples of solving quadratics using the quadratic formula. So in number 2, again, I'm going to figure out what a, b, and c are first. A is 9, b is negative 24, c is 16. I'm going to start by finding the discriminant. That is b squared minus 4ac. My b is negative 24, so I need negative 24 squared minus 4 times my a value times my c value. Now negative 24 squared is positive 576 minus 4 times 9 times 16 is 576. So we have 576 minus 576, which is 0. So our discriminant here is 0. If we have a discriminant of 0, that means we're going to have one real solution. We should only get one answer for our roots. Now let's figure that out. When we use our quadratic formula, we have x equals negative b, so we have positive 24, plus or minus the square root of our discriminant, which is 0, all over 2 times our a value, which is 9. Anytime you have a discriminant of 0, you're always going to get this plus or minus root 0 in your quadratic formula. So now when we simplify, the square root of 0 is 0, so 24 plus or minus that is just going to be 24, and 2 times 9 is 18, and now both of these are divisible by 6, so we're left with 4 over 3. So our graph is only going to touch the x-axis once, and that is at the x value of 4 over 3. In number 3, we need to make it in standard form first, and then figure out what a, b, and c are. So I'm going to start by subtracting the 3x. You could also subtract the x squared. It doesn't matter which way it goes. So if we subtract the 3x, we have x squared minus 3x equal to 0. My a is the number attached to the x squared. That's the coefficient of x squared. So a here is 1. B is negative 3. And c, there is no constant here, so our value of c is 0. To find our discriminant, we need negative 3 squared minus 4 times a times c. Negative 3 squared is 9, and then anything times 0 is 0, so our discriminant is just 9. That means we're going to have two real solutions because our discriminant is a positive number. So let's find out what those solutions are. We have negative b. Well, b was negative 3, so now we have positive 3 plus or minus the square root of our discriminant all over 2 times 1, which is 2. So we've got one x value that's going to be at 3 plus 3, because the square root of 9 is 3, over 2. One that's at 3 minus 3 over 2. 3 plus 3 is 6, divided by 2 is 3. So we have a root at 3, and then 3 minus 3 is 0, divided by 2 is 0. Let's do one more example. X squared plus 3x plus 6 equal to 0. A is 1, B is 3, C is 6. For our discriminant, we need 3 squared minus 4 times 1 times 6. 3 squared is 9. Negative 4 times 1 is negative 4 times 6 is negative 24. And 9 minus 24 is negative 15. So this time we have a discriminant that is negative. Negative discriminant. That means we are not going to have any real number solutions. So I'm just going to put a line through the roots because, like I said, there are no solutions to this. It's never going to cross the x-axis. So we're not going to have any roots because that's the point of a root, is to figure out where we're crossing the x-axis. So you can put a slash through it. You could write NS for no solution. But the point here is that if we have 0 solutions, we shouldn't have any roots. Those two things go together perfectly.